Just to introduce myself, my name's Ian Stokes. I'm network software engineer for Intel. Been working the last few years as a developer on OVS DPDK specifically, but I suppose over the course of the last 9 months, I've kind of moved into more of a committer role within the OVS DPDK community, looking at the DPDK aspect and patches, so running through the validation reviews and the usual issues we hit. So I kind of thought just, the reason for doing this live is that we just came across a few use cases where underneath the hood, we're using something like the eDev API, which is great because we have different devices. And over the last year, we've started to get more patches from different vendors. And that's great because it means they're using more devices with DPDK. But when we receive patches, it's typically because something's broken with their device. And so we took a quick look. OK, some of these things can just be the behavior of OVS, but some of these things can be the behavior of how the PMD driver is behaving in DPDK. So I suppose with that in mind, just the content of what I'd look at today, I just want to cut down to like a narrow view of some of the problems we hit. So in this case, I've chosen MTU configuration steps in OVS, DPDK specifically. We look at a high level how it actually works, just so people are familiar. It won't be a deep code dive or anything, but just so people are familiar with the different stages. And we're going to do a case study, how things like device-specific overhead affects it, how the scatter requirements can affect it, and essentially how device configuration states affect it. And hopefully, some of these, there's solutions already in place. Some of them, there are probably solutions still yet to come. And hopefully, you guys will have some good input on, how these solutions can be done better, maybe in DPDK, possibly on the OVS side. So I suppose at a high level, if you were to configure an MTU in OVS DPDK to receive jumbo frames, there's kind of 3 stages, you could say. You'd validate a frame, so somebody writes an MTU request to your OVS DB, and you'd validate it. You might create a mempool then based on that MTU size, and then you configure it. So I suppose as part of the validation, it's just important to kind of realize, well, what are the steps there? So somebody writes in their value to OVS DB. That's fine. It's a layer 3 MTU they're specifying or requesting. So they don't account for the layer 2 or CRC headers, nothing like that. So within OVS DPDK, we do a small bit of work to make sure that they're not surpassing the upper bound limit or the maximum packet we support, which would be 9728 bytes. So that'll be the first thing we do. We won't even touch the DPDK device if possible. We'll just try and make sure, by the time you add on your layer 2 overhead and anything else, you're not going over this. And the idea here is that if you are, we'd rather just fail fast and tell the user, no, we can't support it, your device will keep working as usual. And that would just be the idea here. We don't even try to touch the DV if possible. We don't want to go into setting MTUs or anything like that. Just as an information side on, what's the impact of setting an MTU? Well, on the mempool side, I suppose your MTU plays directly into the size of your mbuff size header. So in OVS DPDK, it's calculated as your requested MTU, your L2 header, and your CRC, some packet mbuff headroom, and then we'll do some rounding, just memory alignment. But I suppose this is just to call out the relationship between setting an MTU in OVS DPDK and how it impacts the mbuff size, which leads to your mempool creation. And I suppose the last step then, just doing your configuration, your initialization of the actual DPDK device in OVS. So a few important things to call out. The device is stopped by the time you get to configuring. It's actually stopped before you even create your mempool. But your MTU is configured with a call to RT eDev set MTU. You pass your port ID and your MTU. If that's successful, there'll be various other configurations carried out within OVS, so TXQ and RxQ set up, and then OVS will start the device again. And so while all this is happening, your device isn't accessible. It's being stopped and it's being started. So you're not processing packets during this time on this port. So I suppose just the first kind of case study we can look at would be device-specific overhead. So this is a real customer case. Somebody came in the mailing list, or they'll either report it back to people like Red Hat or Intel, and they said, look, we have an IXGB device. We're requesting the upper bound MTU request of 9710. Yeah, so from the OVS DPDK point of view, the frame length will be validated. It's fine. The mempool will be created, and your device configured and initialized. Works perfectly. Then they said, well, we're using an I40 PMD now, and we try to configure the same thing. So we have an MTU request 9710. OVS validates the frame length to being OK. Your mempool is created, and then your device configured fails. And we dig in a little, we see, well, there's an invalid argument error after being passed back. And we say, where'd that come from? It comes from your RT eDev set MTU. And so, this is the eDev API, and this lovely thing about this is that, underneath the hood, all the different PMDs will have their own specific implementation for setting the MTU. But as the first step, at least in 1711 when we were looking at it, the IXGB device was using, to validate a frame length there within the IXGB PMD library, it was using MTU, ether header length, and CRC length. So there was an extra 18 bytes being added, which is fine. That brought your total packet length to 9728. That's OK. When we looked at I40E, though, we spotted that, well, there's your MTU, your header length, your CRC, but it has to account for 2 VLAN tags. So there's an extra 8 bytes being passed that it's going to try and validate. And in this case, you're going to 9736. So you've actually went over your upper bound. And so the MTU was quite right to say this is an invalid argument. You can't set this value and fail. But it kind of got us thinking that, well, OK, so for a customer, if they're using this, if they are requesting the upper bound and they're moving between IXGB devices and I40 devices, how do they know that, well, the upper bound is 9702 for an I40 device? How do they know that the IXGB device is 9710? What can they request? And how does that work, and how do we handle it? And at first I thought, OK, maybe this is just for the Intel cards. These are kind of Intel vendors. But took a deeper dive and just looked through some code across the board. And what I kind of started noticing is that, well, with different PMD drivers, there is different overhead being considered when they're validating as part of their set MTU. From QED down to their X, you'll see that it's ether header length and CRC, so it's 18 bytes. When we get to things like the EM1000, the IGB, they account for 1 VLAN tag, so that's 22 bytes. For the BNXT and I40E, it's 26 bytes for 2 VLAN tag size. For the Merville, is there anybody from Merville here who can answer this? There's a MV MH size, which I couldn't find even from code inspection. So again, even from my point of view, I couldn't know digging into the code. So if anybody can answer that, I'd actually be impressed. But it just kind of goes to show that, you know, even from a developer side looking through the code, it can be tough to tell what the overhead is. And this isn't even a very exhaustive list. There's going to be some devices which are just writing to a hardware register with the requested MTU, and then you just wait to hear back whether that was set or not. So from our point of view in OVS, you know, this was a real customer issue. How do we work around it? Solution that we just came to at the time was, look, let's just assume worst case scenario. We couldn't see this overhead being exposed anywhere, so we said, when you do this validation, you'll essentially just have to account for 2 VLAN sizes and make sure it's not bigger than your maximum supported packet. The problem, I suppose, with this really is that, again, if you're a customer using a device that doesn't account for VLANs, your upper bound is being reduced by 8 bytes. If you're counting just 1 VLAN, then it's reduced by 4 bytes, I guess. And why is that? Why are we provisioning for worst case scenario in this case? And I guess that leads to the solution, really, the DPDK solution. I think from the OVS, from the community call, when we spoke through it, we said, you know, it would be really nice if we could expose these device-specific overheads for the PMD. It could be done a number of ways. We're not sold on either one here, but somebody said, look, you already have like the get and set MTU methods. Is there something that you can get max MTU and just return a defined value for that PMD? Or maybe you don't even extend the API. Maybe you just add in some info into the dev info struct to say, this is my required overhead. So we're open to other solutions here as well. But again, a simple problem, but it's just something that, as I said, we have no visibility into this, and it does affect when we call the set MTU functionality. At that stage, we already stopped the device, and to find out at that stage that this value isn't applicable, we'd like to see that a bit sooner to avoid even stopping the device altogether if we could. So that's just the first case study. The second one we looked at then was scatter requirements. So in typical fashion, some PMDs can require scatter to be explicitly set to receive jumbo frames, and that's been fine. Probably in testing to date, what was happening was that the scatter was supported within the devices. So when we tested with an I40 PMD, it's actually not required. It can be handled as I40 set MTU. It's handled at that level. So even if you explicitly set scatter enabled for the device before you call the etdev set MTU, the I40 will actually handle it underneath the hood for you. It allows OVS to be a bit blissfully ignorant, I would argue. For IXGB, it's required scatter has to be set pre-DPDK 1711. I think in DPDK 1711, possibly .1, I think there was a change added where essentially it's not required anymore. You can set it beforehand and it will be OK. Underneath the hood again, it will be handled as part of IXGB set MTU. I think the only requirement is that the device has to be stopped before you can enable scatter, essentially. But so these two cases are fine. We can set it explicitly in OVS, and it was working even between releases, between 1611, 1705, and then 1711. It worked for IXGB as well in I40, so we were happy. And for IGB, it's just been required. You have to have it enabled for the first time the IGB device actually starts to enable scatter mode, so we've always explicitly called it when adding the port. But then our colleagues at Metronome came to us and said, well, actually, we have a problem. We've been testing with our net NFP device, and we support setting the MTU, but we don't support the scatter offload. And this is causing an error in our configuration because of the way it's laid out in OVS. So in OVS, we will enable scatter, then call edev set MTU, and your configuration will be called. And essentially, it was breaking the device startup for them. So I suppose, kind of full disclosure, they had actually a better solution at the time, and they had said, well, rather than just setting this, why don't we just look into the RX offload capabilities? And it should be listed there that, hey, I support scatter, so I can enable it. And if it's not listed for NFP, then you don't enable it. And that would have been OK. But I suppose when we looked at it then, that wasn't fully implemented, at least not in 17.11. And I think in master and DPDK at the time, it was in the process of being implemented. So what solution did we kind of have to come about for it? Sorry now, guys. Yeah. So the solution that came out is probably one of my least favorite solutions I've ever seen. And let me just say, there's about 3 lines of code and about 12 lines of comments added above it explaining why we're doing this and why it gets an exception here. We just kind of said, you know, to date, nobody else had given us feedback saying, well, my device doesn't need it or I do need it. And we looked in, the API at the time was being developed in RX offload, so it was like, look, this should be in place for the next LTS release, which we would be moving to. But in the meantime, we have to kind of support this. And like, this is just a really horrible solution. But again, we had to, it's the only time I think we ever actually allow a specific check for a driver. And this is the problem. It resolved it for NFP, but what if there's another device? It doesn't fix their problem at all. They're still stuck with it. So again, we have to kind of go back to the better solution, really, which I think is coming, which is, I suppose, OVS. Once the RX offloaded capability and are listed correctly for all the devices, they're complete, then I suppose we can actually use that as some type of hint as regards, look, do you need to enable this explicitly or not? That would probably be the best thing, and I think that will be in place for 18.11 if and when we kind of move to that. Another alternative would be just what happened with the IXGB, that the way scatter support was just changed to be handled underneath edev set MTU, and it's just taken out of the application's use case to figure out is it needed or not. 2 possible ones. I probably think the RX offload capability is probably the better of the 2. But yeah, that's the alternative that was discussed as well. Maybe just scatters should be handled as part of edev set MTU. And I suppose then just the last case we kind of look at then, case study 3, so device configuration state and requirements. So we kind of said the third and final stage of OVS DPDK when it's configuring the MTU would be that, you know, the device is being stopped. I need to set my MTU, initialize a bunch of other things like your RX queues, and then you'll start your device, and that's fine. So in testing about a year ago, this worked for i40 and iXGB. i40 has a requirement under the hood that the device is stopped. Otherwise, you get just device busy error if you try and set the MTU while it's running. iXGB only has to be stopped if you are required to enable scatter. But we had a patch submitted from Red Hat essentially trying to enable QEDE. And they found, well, actually, the QEDE PMD at the time, as part of its edev set MTU, it was calling stop device and start device within the set MTU functionality itself. And obviously in OVS, the problem is that, OK, we'd already stopped the device. It gets called set MTU, but a bunch of stuff still hasn't been configured, like your TX queues, your RX queues. And so now within the set MTU call, it's being started. So there was a difference in behavior underneath the hood between how they were setting the MTUs. Now, full disclosure, this is being fixed, and I think QED now does work with a device, even if it's stopped or started, it takes into account that, and that's been backported to 17.11.1 and 16.11. So I suppose from the OVS community point of view, at the time, there was no workaround. We just believe that, look, this is a change that needs to go into the DPDK side and needs to align its behavior a bit more uniform. As we said, they have been backported. I suppose the only problem you'd have now is OVS DPDK sticks LTS releases. So if a customer comes to use OVS 2.8, that uses DPDK 1705 as non-LTS, and I don't believe that patch is actually being backported there. So we just have to push a user to either OVS 2.9 or later, or else OVS 2.7, because in those cases they'll be using the LTS and it will work for the QED driver. I suppose the solution, yeah, it's already in place, but I guess the lesson here really is that, you know, the underlying behavior, the details can be different, but there should be a general underlying behavior that we can all sign up to and agree to. If we're using an eatdev API and then under the hood you're doing your own thing, for people like OVS, DPDK, we're trying to keep, you know, hardware agnostic, we're trying to help all the devices, and we see these problems cropping up. And that's kind of the thing. And I don't know, is that there for DPDK yet, or DPDK yet, that like you have this API, and if you're calling, let's say, setMTU, is it stated somewhere that, well, we expect that the device has been stopped, or that, you know, such and such a value is expected, these cases have been taken care of. And maybe that's somewhere that we need to start looking into. So I suppose just a conclusion and discussion, I suppose, then on a positive note, without just giving out the whole time, I suppose 3 years ago, myself and my colleague Sagesh gave a lightning talk just on, you know, code-specific implementations in OVS DPDK, and we're happy to. I'm definitely happy to say that like the things like eatdev are really, really helping. I would say 90% of the cases is getting us over the line, and it's behaving the way it should be, and that's really good. So like that's. Kudos to the DPDK community for helping out with that and help drive that. I think we're really seeing those efforts pay off in OVS DPDK. Look, the corner cases, I suppose they're always going to exist, but it's something that can we give a bit more visibility and how to make developers a bit more aware just as you're kind of setting your underneath methods and what we can adhere to. And look, I suppose just a few warnings, you know, general guidance, if there's any device-specific overhead or anything like that, for as we saw in the first case, maybe that's an API extension, maybe it's device info, but making that kind of available to the application can be quite useful in some cases. We've already seen a bunch of things. I'm glad to hear most talks I've seen now, everybody's talking about exposing capabilities, which is really required. Can't emphasize that enough. And I suppose it's great to expose the capabilities, but again, just look, follow uniform behavior in the underlying API implementations. The details can be different, but you know, we should all adhere that if the application is calling on two different completely pieces of hardware, there should be some semblance of, you know, what I can expect and what I can't expect. So yeah, that's my presentation. If anybody has questions or input, yeah, I'd be more than happy.
Actually, you started talking with me about the idea of having some kind of CI, continuous integration with OVS.
Yeah.
Would you like to elaborate a little?
Yes, so this is kind of a discussion that's being driven mainly out of Red Hat to date with our colleague Aaron. We've been just trying to improve the OVS DPDK unit tests. So to date, it's really kind of only taking care of EL, memory initialization, adding a physical device, and virtual ports. I suppose we're trying to push it a bit further going forward down the line. That there's a bunch of work going in that we'd like to get a stage where maybe we have a public test bed with a bunch of different hardware from different vendors. The reason I think this is going to be important is that we've seen the kind of trouble you can just trying to get setting an MTU. We're trying to think down the line when we're getting into enabling hardware offload. And how do we deal with if somebody from Intel submits a patch, does it break something on Mellanox or vice versa? So we kind of think that maybe going down this public route would really help with that and making it a public test bed. I suppose as an aside to help with that, typically we've always spoken that we stick to LTS releases. There's been a lot of feedback and work in the OVS DPDK community for Intel and Mellanox that and Red Hat, there should be a push to actually maybe have an experimental branch that tracks DPDK master. So now, if we're moving to an LTS, we should have visibility of any issues much earlier. So for example, I think this year there might have been something introduced in 1802 around vhost. We were looking at upgrading to 1808, and one of our developers in Red Hat found an issue and spotted, well, this has actually been there in a few releases. So that's fine. It's in time to fix it for 1811, but really we want to get this feedback loop coming back much sooner. We kind of feel as a downstream consumer of DPDK, we probably do have a lot to help and to give input into the DPDK community, and we can do a better job on that side. But I think having a nightly build like this will definitely help something like that. And again, enabling different hardware. So I think if there's any vendors who are interested on that, either chat to myself or Aaron. I think over you volunteered from Mellanox, so I head up here, so that'd be interesting. Yep.
On the MTU issue, I think you raise a good point that there's just a simple oversight in that the device information does not have the fields to express the minimum and maximum MTU values. They're there in the Linux kernel. They're there for most hardware. People know them. I actually looked at the Intel devices in the Linux kernel, report the right values. So you would, we could go put them on the ethdev info. We could go fix every driver in a day or so. But the problem is that that's going to be a binary ABI breakage. Now we have an LTS release coming up. Maybe we should just spend the time and shove it in. And
Yeah, and that's the perfect discussion. I think that would be perfect here.
I mean, there's time left. We could get it in for 1811. It's really not that hard to iterate over, you know, X number of devices and put in those two values.
As just the corner case that concerned me there was like where we just don't see that maybe on some of the hardware devices. I hope there wouldn't be a problem, but maybe some people have hardware registers where they don't know, and it's I don't want it just to be something to be in for some drivers and not for others. So that's, I suppose, the other issue.
The real problem is something like that. We have vendors that exist that have out of tree, not in the DPDK devices. But I'll be blunt. I'm a developer. That's not my problem. If they're out of tree, they need it.
Regarding the continuous integration, so tomorrow we'll be talking about the Open Lab CI, and I mean here at UNH we're doing the DPDK performance testing, and like right now we have Intel, Mellanox, and NXP hardware, and talk of doing more like unit testing at the lab. So we can talk.
If there's something, and that's one of the things we highlighted. Actually, we were going to chat to you guys on tomorrow's talk, because that could be, as we said, either a roadmap to how and go do it, or it's maybe something that we can all chip in and help already. I suppose that's the thing. It's just nice to have one central location and have all the hardware there. Again, it's just another tool to enable development faster. So that could be a really fruitful talk. Thanks.
Yeah, just to add, I mean, the interface is obviously one aspect that has to be right, but I guess all the vendors with their PMDs have to kind of roll in and get the changes in, and at the same time as well, because I think that's what we saw with like that kind of hack for scatter, was really because the interface was there, but maybe it wasn't enforced enough that all the vendors did it at the same time in the same release. Yeah,
and that was exactly the issue. I think we looked into getting it backported and things like that, but yeah, it was present for some and just not for others. So
I think we can have the interface right, but it's up to the vendors to make sure that they, if there's a request, hey, we're changing the interface or we're doing this, that they have it in on time on that release. Yep. And another reason we wanted to put that in is because we didn't trust that all the vendors had done that, and we didn't want to break cards. Yeah. We didn't want to change stuff. So the interface is one thing, but the implementation has to be done, I think, on time by the vendors as well.
Yeah, and I think that's why I think it makes sense to have this talk here as well. There has to be like a general agreement that vendors can approach and kind of agree to have it by a certain date. Otherwise, yeah, OVS, we're just kind of left in the same old boat again. So, yeah, Roop.
For this specific one, it has been already discussed in mailing this that scatter RX, mux RX length packet and MTU, they are related, and that's the causing trouble, and we agreed that that's not clear. So it is kind of ETH dev problem here to clarify it so that PMDs can implement properly. So as Steven suggested, perhaps we can take over that one in this release, because it was already agreed that is confusing.
Yeah. That would be helpful, yeah, definitely.
Any other questions? No? Thank you.